Hi folks, welcome back to Physics with Captain Rod. I'm making this video to help just conceptually describe what batteries are and how they work. I've got some pictures on the left here I'd like you to focus on here. I've got 4 different types of batteries you might find in your everyday lives here. I've got a picture of one of these 1.5 volt D cells, picture of one of these 9 volts watch battery. I believe this one is a 3 volt battery, and there's a picture of a stereotypical car battery. Usually these are 12 volt batteries. And here's some of the things all these batteries have in common. All right, every one of them has a pair of terminals, one marked plus, one marked minus. Over here, the positive terminal, you can see it marked right there on the battery, is this side. The negative terminal is over here. With these little rectangular batteries, we've got our pair of terminals here and here. With the our 12 volt battery here, one is always marked plus, one minus. Right? Another thing that they all have in common, they all have a voltage associated with them. Again, I went through this. This was a 1.5 volt, 9, 3, and 12. Now let's talk about that voltage. Remember, that's a unit of electric potential. And electric potential is defined as potential energy per unit charge. So the potential of the battery is related somehow to how much energy is stored within it. Notice this, that I can rewrite this potential energy equals charge times potential. So typically the higher the potential, the higher the more energy is stored within the battery, the more work it can do. But another factor here is this, charge. So somehow there is a measure of how much charge is available to be pushed through the circuit. And that measurement is called an amp hour rating. So batteries will typically have a potential and an amp hour rating. Now if we look at an amp hour and we look at what it is, an amp is a coulomb per second and an hour is 3,600 seconds. And you'll notice the seconds divide out and we get 3,600 coulombs. Actual numerical value here, not super important. The big thing is this, that an amp hour typically has units of coulombs, and it represents how much charge is available to be pushed through the circuit. Now usually the average consumer doesn't look at things in terms of charge. Let me talk about why the amp hour rating is such a nice convenient way to look at a battery. Right, I run an electric trolling motor on the front of my boat, and I buy a 12 volt deep cycle battery to power it, and I usually look for batteries that are around 100 amp hours. So got my battery here, 100 amp hour battery, and what that 100 amp hour battery basically means is this: if I were to hook it and have an electrical draw of say 2 amps, it would run for 50 hours. Or if I had an electrical draw of 25 amps, it would run for around 4 hours, or maybe a little less. I'll talk about why here in a minute. Or maybe 10 amps for 10 hours and so forth. So the amp hour rating gives you some idea of how long the battery will last under a given load. Now the one thing I'd like to point out is that the amp hour rating is not a 100% absolute. Right? If this battery did in fact last 50 hours with a 2 amp draw, it will not actually last 25 hours with a it will not last 4 hours with a 25 amp draw. Let me talk about why. For higher currents, that typically makes the battery hot, and the battery efficiency goes down. You have more energy converted to heat. So effectively what happens is overall, the higher the current you run, because of losses in efficiency, you'll end up with less time. It might run for 3 or 3.5 or something like that. And if I were to run it for 50 amps, there's certainly no way it's going to give me that 2 hours. The efficiencies can fall off significantly. It might only run for an hour or maybe even less. All right, but it's still a useful measurement for describing how large or how much energy the battery has available, or how much runtime is available for most electrical loads. Now, I want to spend some time talking about the idea of charging a battery and what that means. I think that's one of the most least understood concepts in the whole study of the field of electricity here and how things work. I think that when we charge a battery, most people visualize pumping charge into the battery like it's some sort of storage device, like a bucket of water. That somehow, if we charge this battery here, maybe we decide to charge this, that we're pumping charge into the battery, and it's in some sort of charged state now, and that charge is available for use. And that's not the case at all. So when we talk about charging a battery, what we're talking about is a charge imbalance. batteries store imbalances of charge. Now, the charge typically in batteries is stored chemically. But what I want you to imagine for this video, even though it's not entirely accurate, but I think it's a good way to think about it for understanding this part. Imagine that each terminal is connected to a plate. I'm going to draw these plates maybe in green. So imagine a pair of plates here. These plates are just going to represent, I'm just going to say, the storage capacity, right? But just imagine them being plates. And these plates are each connected to the terminals. Now, when we charge the battery, right, we hook it to a battery charger. This is going to represent my charger. The battery chargers are plugged in, so we have an energy input here. I'm going to put that in the form of work. We got work or energy coming in, because the battery charger has to do work to charge the battery. And what it does, we connect one lead here, another lead here, and what it does is it pulls electrons from one area. So we have electrons moving this way, and it pushes electrons into this terminal. So we're pulling charge from one terminal, pushing charge into another terminal. And what that's doing is it's creating an imbalance of charge. So now, picture my plate here, or my storage area, positively charged. And then on the other side, this plate, imagine it negatively charged. So the charge configuration of the battery, the net charge in the system really isn't changing. The battery stores an imbalance of charge. And then when we unhook the battery, this imbalance of charge basically now represents a potential energy, because it's the position of the charge within the battery that gives this system the ability to do work. It's analogous to this picture I have on the right here. So let me talk about what this is, because I think this will go a long ways towards understanding how batteries work. This is what I call a bucket battery. All right, so imagine a pair of buckets here, right, connected by some sort of pipe that has a valve. Imagine that within the pipe there is some sort of small turbine or something, so that anytime water goes through the pipe, the turbine turns, and it can turn this shaft right here. All right, now imagine we fill one side of the bucket with water. This system right here has a potential energy stored within it, because the position of this water with respect to the rest of the system gives it the ability to do work. When I open the valve, water will flow through the pipe until the two water levels are equalized. As water flows through the pipe, the shaft starts turning, so in theory we could do a little bit of work out. Now this is not a practical battery, and this could not be used in any sort of reasonable way, but I think it does demonstrate the concept pretty well. As the water level goes down and equalizes, at this point right here, the system doesn't have any ability to do work anymore. So we would say, let me say it's quote uncharged, unquote. If I want to recharge the system so that I can do work, what I would need to do is I'd have to have, whoops, let me draw that in a different color. I would have to hook it to some sort of pump. Right, so this circle is going to represent my pump. I would have to plug the pump in, so there would be an energy, or I'll say we have work coming in. The pump, we would put a hose here, put the other hose here, and what we would do is we would pump water in this direction until the system looks like this again. This would be the charged state of the system. This, the uncharged state of the system. Now, a very important thing to recognize here is that when we charge my bucket battery here, we are not adding water to or taking water away. The system, as defined like this, is not changing in the amount of water that it carries. Right? All we're doing is changing the relative location of the water with respect to the rest of the system. This is how batteries work when we charge them. We're not adding a net charge to the battery in any way, shape, or form. We're creating an imbalance of charge. Just like over here, we're creating an imbalance of where the water is within the system. So, this was meant to be just a conceptual video. That's basically what batteries do. They store an imbalance of charge. Typically it's stored chemically, and I'll make another video maybe about the details of that. It's important to realize that they store a charge imbalance, not not a quantitative amount of charge within the battery. It's not like the battery now has a net charge, or it's full of charge, or anything like that. It just has a charge imbalance associated with it. which now creates, we now have a potential difference between these terminals. And now what happens is, if I hook this and make it part of some sort of electrical circuit, in reality what happens is electrons are going to move through the circuit in this direction, and we would say the battery's discharging. We would have an electrical current running whatever this part of the system is. Now, usually when we talk about electrical current, we talk about positive charge carriers. The positive direction, believe it or not, for this circuit situation would actually be this way. That would be the positive direction, because we always assume positive charge carriers when we are talking about electrical current. And I think that's probably enough for this video. I just wanted to, again, make a conceptual video, a little bit about how they work, how and why they work, and I'll save some of the math for this for another time. All right. Hope that helped. Have a great day.